What's up, math scholars? In this video tutorial, I'm going to be explaining the answers to questions 1 through 24 from the June 2022 Geometry Regents. Hope you enjoy it. Question number 1. Triangle A prime B prime C prime is the image of triangle ABC after dilation centered at the origin. So they give us the coordinates ABC and they ask if the coordinates of A prime are negative 4 comma 2, the coordinates of B prime are what? So our objective for this problem is to determine the coordinates of B prime. So what do we know? We know that this is a dilation, and I'm going to say that arguably this is the most important word in this problem. How are we going to figure out what the coordinates of B prime are? Well, I remember that a dilation is when a shape either increases or decreases in size proportionally from a specified point. In this case, it's the origin. So what can we do? Well, I know if A prime is negative 4 comma 2, then that's going to tell me that the scale factor is 2, meaning that it's doubling in size because if A is negative 2 comma 1 and A prime is negative 4 comma 2, then it's doubling in size. So what does that mean? That means that clearly B prime has got to be 4 comma 8 and C prime has got to be 4 comma negative 6 because again we're doubling the x and y coordinates by 2. Is that an option? Is B prime 4 comma 8? Do we see that here? And certainly we do. The correct answer for question number 1 is option 2. Question number 2. In the diagram below, a plane intersects a square pyramid parallel to its base. And this, of course, is the base right here. Which two-dimensional shape describes this cross-section? Is it a circle, square, triangle, or pentagon? Well, I'll recall that a cross-section is a surface of shape that would be exposed by making a straight cut right through it at one or multiple points. So here we have a few examples involving a cone. On the right side, we've got a pyramid. And so if we shift this over, and we'll recognize that this cross-section has got to be parallel to the base, it's going to look a little something like this. And what shape do we have here? Is it a circle, triangle, pentagon? Nope. It, of course, is option number 2, a square. Question number 3. In the diagram below, triangle CDE is the image of triangle CAB after dilation of DE over AB centered at C. So we have got two similar triangles here. It says which statement is always true. We've got 4 options, and we can see that they're involving sine and cosine, meaning we're going to be using our trig ratios. We're going to return to that in a moment. First, however, I'm going to mark up this diagram to reflect a few truths. So we know that if we've got two similar triangles, which we have here, the side lengths change between similar triangles, right? But the angles do not. So the two right angles in red stay the same. We know that angle C is shared between both the small and the large triangle. So clearly that's the same. And then finally in blue, we've got this angle, which we can describe as angle BAC, and then angles EDC. Here on out, we're just going to call these the blue angle. And we know that the blue angles are congruent. They're the same. And so let's take a look at these 4 options. We'll start with options 1 and 3 because they're both involving sine. And we know that when we think about SOHCAHTOA, when we think about sine of an angle, it's going to be opposite over hypotenuse. So which is always true? We'll start with option number 3. So the sine of A, which happens to be the same as the sine of D, again because these are congruent angles, equals DE over CD. No, you know what? That does not work because DE is the adjacent side and CD is the hypotenuse, but we're talking about sine, so we can rule out option number 3. What about option number 1? It says the sine of A, and we know that the blue angles are congruent, is equal to what over what? So the sine of D equals CE, which is the opposite side, over CD. The hypotenuse, you know what? That does work. That does check out. This is absolutely true because we're talking about the sine of A. Option 1 is the correct answer. Question number 4. A regular pentagon is rotated about its center. What is the minimum number of degrees needed to carry the pentagon onto itself? So what exactly does that mean? Well, we recognize that a pentagon is a 5-sided shape, and because it's a regular pentagon, all the sides are equal or congruent, it's being rotated around its center. And so what does that mean? That means that in order for it to carry the pentagon onto itself, that means we're going to be rotating it, and it's going to be looking exactly the same as it does in the start. So this involves, of course, rotational symmetry. What is the formula? It involves 360 degrees divided by n, which is the number of sides. So here, for example, in this triangle, if it's 360 degrees, right, divided by 3, that's going to give us 120. So we know that 120 degrees, it's going to map onto itself or carry onto itself. And then another 120 for a total 240 degrees. And then 360, it's going to return all the way around. But how do we approach question number 4? Well, it's going to be 360 divided by n. In this case, n is 5. And so what does that give us? That gives us 72. Is that an option? It is. The correct answer is option number 1. Question number 5, it says on the set of axes below, we've got two triangles congruent to one another, and it says triangle ABC maps onto triangle A prime, B prime, C prime after what kind of transformation? Let's start with option number 1, a reflection over the line y equals negative x. Presumably, you spent some time doing this in algebra, and I know that if this is the case, then if this is A prime should be approximately right here, right? And yet it's not, it's all the way over here. So what we can do is eliminate option 1 as a possibility. Let's take a look at option 2. It says a reflection over the line y equals negative x plus 2. So here's what I know. It's going to have the same slope as the previous option, but the y-intercept is going to be 2. So we're going to simply go up 2. And then the slope's going to be right here. And so again, if this is A prime should be right here, but A prime is all the way over here. So this one can't work either. Let's take a look at the second two options, which in contrast to the first two were reflections. Now we're going to talk a little bit about rotations. All right. Now let's take a look at options 3 and 4. We're going to start with 4, where we're going to be rotating 180 degrees centered at the origin, meaning that what? Well, I'm going to shift over. So we've got a brand new diagram, and I know that if we are going to be rotating 180 degrees at the origin, that's going to be around this point. I know then that if this is B prime, then B should be situated right there also on the y-axis. Sadly, that's not the case. I can see B is over here. And if we actually apply this algorithm, if we apply this rule, we can verify that sadly this is not going to check out. So let's do this with point B. So point B is right here, and I can see that point B is 2 comma, not 2 comma 4, but 2 comma 6. Okay, great. So here's what I know. If we're going to be rotating around rotating around the origin, and we're talking about B, 2 comma 6 should work out to be what? It should work out to be negative 2 comma negative 6, and that makes sense. And yet when I start at the origin and I shift 2 to the left and I go down 6, B prime should be situated right here, and yet it's not. B prime is over here, so we can rule out option 4. We know then that it's got to be option 3, and let's figure out why. So it says it's yet again another rotation of 180 degrees. This is the rule when we're rotating around the origin. Instead, it's being centered at 1, 1. So we're going to find 1, 1 right here. And here is what I know. We can start with B again. And what is the slope from this new point, 1 comma 1, to B? Let's count up. It's 5 over 1. And what is the inverse of that? Okay, so this is going to be up 5, 1 to the right, down 5 to the left 1. And you know what? They share the same slope, 5 over 1. So that does check out. Let's do this again for A to A prime. And we're going to see if it works, then indeed this is a 180-degree rotation. And I can see that this is up 1 and then to the right 5. Beautiful. At A prime, it's going to be up 1 and then to the right 5. They're the same distance from the center of rotation. They've got the same slope. Option 3 is the correct answer. Question number 6. Right triangle TMR is a scaling triangle with a right angle at M. Which equation is true? Well, as always, the first thing that we're going to want to do is sketch out this triangle. And I recognize that it says right angle at M. So this is going to be M. This will be T. And then this will be R. Great. I also see that options 1 through 4 involve sine and cosine. So we're going to be implementing our understanding of trig ratios. And before I go on any further, I'm going to label these sides. I'm going to color code them. So we'll have purple, green, and blue. I like that. And now, typically, right, we work through the problem to identify the correct answer. I'm going to tell you right now, option 3 is the correct answer. I'm going to explain why, and then I'm going to offer some contrast to the other options. So correct answer is 3, and here's why. I know that if it's the sine of t, sine is going to be opposite over hypotenuse. So if we're sitting right here, and let's set up this equation. Okay, sine of t is going to be right here, and then I know that it's going to be opposite over hypotenuse. So it's going to be green over blue, so it's going to be mr over tr. Great. And then I'm going to be thinking about it from the perspective of cosine of r. So this is a cosine. This is angle r. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse, again, is green over red. So it's going to be mr over tr. That makes sense. That seems pretty easy. This is the correct answer. So let's talk about these other options. Well, I know that when we're looking at option 1 and option 4, they both involve angle M. And you know what? We're never going to be using angle M when we're involving trig ratios. We're only going to be talking about the angles that are not 90 degrees. So we can eliminate option 1 and then option 4. And then let's take a look at option 2. So option 2 is the sine of r. And all right, so we're right here, sine of r, and we know it's going to be opposite over hypotenuse. So it's going to be purple mt over blue tr. All right, and for this to check out and work, it should be purple over blue again, but it's going to be the cosine of r. So it's going to be the adjacent over hypotenuse. So instead, it's going to be mr over tr. And you know what? Clearly, these are not balanced. These do not match. Option 3 is the correct answer. Question number 7. The diagram below of triangle AED and segment ABCD, and here it says that segment AE is congruent to DE. All right, so let's mark this up. I can see that this side is congruent to this side, and it's saying to us which statement is always true. We've got 4 options to choose from. But before I go on any further, one of the things I recognize is that we're going to be working with an isosceles triangle. And I know that an isosceles triangle is one where 2 sides are congruent or the same. And another property of isosceles triangles is that base angles are congruent. That's critical. And so I'm going to mark up this diagram to reflect that. And it says, which statement is always true? It says, is side EB congruent to EC? So this side certainly looks like similar, if not the same as its length, but there's nothing here that can prove that definitively, right? Because what we're looking for is something that is always true, and we just don't know. We just can't say for certain. So we're going to have to rule out option number 1. Option 2, it says AC is congruent to DB. So AC is congruent to DB. It seems like it, right? If we were maybe applying the segment addition postulate, but again, we don't know what the length is of this and this, of AB and CD. So we're going to have to rule out option number 2. Option 3, angle EBA is congruent to ECD. Again, we don't know where these lines are. There's nothing definitive to help us determine if option 3 is the correct answer. So we're going to say, no, we don't know. Could be true, but again, it's got to be always true. So that leaves us with option 4, angle EAC, which is indicated here by this blue angle, is congruent to EDB. Yeah, definitely. Option 4 is the correct answer. Question number 8. As shown in the diagram below, right triangle ABC has side lengths of 8 and 15. If this triangle is continuously rotated around side length AC, the resulting figure will be what? Well, we've got options as a right cone, and then we've got a right cylinder. And I know that right cylinders would not work. So we're going to eliminate options 3 and 4, leaving us, of course, with 1 and 2. Well, what makes more sense? I'm going to mark up this diagram. And I know that if we're rotating right around AC, it's going to look a little something like this. Okay. And I know that B is going to work its way around like right here, right? And what does that mean? That means that 8 is going to be the height. That means that 15 is going to be the radius. And is that an option? It is option number 1. Question number 9. In the diagram below, lines K and L intersect line M and N at points A, B, C, and D. And our objective is to determine which statement is sufficient to prove that ABCD is a parallelogram. And we've got 4 options involving angles. The first thing that we're going to need to do is recognize that our objective is to prove that this is a parallelogram. And in order to do that, we're going to need to know the properties of parallelograms. And so we've got 4 that we're looking at right here, including opposite sides are parallel. And so that's going to be our objective right now. We're going to try to prove that opposite sides are parallel. And so we want K and L to be parallel, and we want M and N to be parallel. But in order for us to do that, we're going to need to think about angle relationships. And so what angle relationships are critical as we explore the 4 options underneath. And so when we look at options 1, it says simply angle 1 and angle 3 are congruent. And so if 1 and 3 are congruent, then we can prove that M is parallel to N, but that's not sufficient to prove that all 2 pairs of opposite sides are parallel. So we can rule out option 1, and we can rule out option 2 for the very same reason. So let's take a look at option number 3. So here's what I know. It says that angle 2 is congruent to angle 5, and so let's mark up the diagram. Angle 2 is congruent to angle 5. And if angle 2 is congruent to angle 5, that's an example of alternate interior angles. And so if we're talking about alternate interior angles, then we know that in this example on the right, those lines are parallel. And again, we can prove that this line K, is parallel to line L. And then let's take a look at the second half of option number 3. Angle 5 is congruent to angle 7. So if angle 5 is congruent to angle 7, what do I know? Those are, in fact, corresponding angles. And so we can now prove that line M is parallel to line N, meaning that we've just proved that ABCD is a parallelogram because opposite sides are parallel. Question number 10. Which transformation does not always preserve distance? And before I do anything else, I'm going to highlight the word not. I would encourage you guys to always circle that, because this means that 3 of the 4 options will preserve distance. 1 will not. We're looking for the one that is not like the other. So what kind of transformation are we talking about? Is it a translation, a reflection, a rotation? It's a dilation. And I'm pretty sure you guys know that, because we'll recall that dilations are not always rigid motions, so they're not always preserving distance. And what is the obvious giveaway? Well, here, for example, we've got a shift. It's a translation. It's the x-coordinate simply increasing by 2 units. But when we look at option 3, which is the correct answer, we will see that that coordinate is being multiplied by 2. And y is simply they're subtracting a single unit from it. But this right here, this 2x, is the giveaway. And now what would that look like in practice if we're talking about a dilation? Well, let's say, for example, if we're going from xy to 2x comma x minus 1, well, if it's 2 comma 1, 2 multiplied by 2 is 4. 1 minus 1 is 0. So we're going to go from 2, 1 to 4, 0. And then 4, 1, the other length of this red segment, is going to become 8, comma 0, because 4 times 2 is 8. 1 minus 1 is obviously 0. And you'll notice that obviously the distance in this transformation is not preserved. The blue length is twice the length of the red segment. And so here's why option 3 is the correct answer. Question number 11. In the diagram below, we've got EF is parallel to HG, and then we've got all these other dimensions indicated on the diagram. And before I do anything else, I'm going to indicate that this segment is parallel to this segment. Amazing. And our objective is to determine the length of HI. So this is just what we're looking for right here. And in order to solve for this length, we're going to need to figure out what the value of X is. Before we do anything right now, though, we're going to need to analyze this visual and recognize a few things. Well, if we've got parallel lines, maybe we can find some angle relationships. And here's what I know. I know that here we've got an example of alternate interior angles being congruent. And so we've got alternate interior angles here, these blue angles, and then these green angles, of course. Additionally, we have another pair of angles that are congruent. It's FIE and HIG because, let's zoom in. Why is this angle congruent to this? Because of course, vertical angles. And so with this situation, we can now establish that these two triangles are similar. Why are they similar? They're similar because we've got an example of AA, angle. And what do we know about triangles that are similar? We know that we've got corresponding sides are similar. Triangles are in proportion. So what we're going to do is we're going to set up a proportion. And so let's do that right now. All right. The first thing that I'm going to do is set up the proportion. And I know that 5, this length right here, corresponds with 12. EF corresponds with HG. And so let's do that like so. Okay, and then we've got this FI corresponds with HI. And so we're going to set this up like this. 1.4x plus 3 equals 12 over 6.1x minus 6.5. What do we do now? Of course, we're going to do a little cross multiplying. So I know that 12 times 1.4x plus 3 equals 5 times 6.1x minus 6.5. There we go. And so we're, of course, now going to need to distribute. So 12 times 1.4x, 12 times 3. What will that give us? That's going to give us simply 16.8x. 12 times 3 is 36 equals what? 5 times 6.1x is going to give us 36.5 x minus what? I'm using my handy dandy calculator. And that's going to give us 32.5. Beautiful. So now we're going to need to combine like terms. So let's subtract 16.8x from both sides. And when we do, we're going to have 36 equals 36.5x minus 16.8x will give us 13.7x minus 32.5. And we always got to do the opposite. So now let's add 32.5 to both sides. There's a lot going on here, right? Let's shift this over. And when we do that, that's going to give us 68.5 8.5 equals 13.7x. We want to isolate x. To do that, we're going to divide both sides by 13.7. And so x is what? 68.5 divided by 13.7 gives us 5. All right. So that's amazing. I'm going to zoom out just a tad. And here's what I know. You may be tempted, after all this work that we just did, we just determined the value of x. X is 5. You're going to look at the 4 options. You're going to get super excited. You're going to say, wow, there it is. You may want to circle it. But don't forget that that's not the objective. We're not solving for x. Instead, we need to figure out the length of hi. So what we're going to have to do, of course, is plug it in. So it's going to be 6.1 times x, which we just figured out is 5. And when you pop that into your handy dandy calculator, that's going to give us 24. This is the answer. And wouldn't you know, option number 4 is 24. That's the correct answer. Question number 12. The square pyramid below models a toy block made of maple wood. Each side of the base measures 4.5 centimeters, and the height of the pyramid is 10 centimeters. So let's take a moment. Let's label this diagram. The height in red is going to be 10 centimeters. And then because this is a square pyramid, each side length is going to be 4.5 centimeters. That makes sense. All right. If the density of the maple is 0.676 grams per cubic centimeter, what is the mass of the block to the nearest tenth of a gram? So our objective is to figure out the mass of the block. How are we going to do that? We're going to use our handy dandy density formula and recognize that the mass, which is what we're looking for, is equal to the density times the volume. And what's great is that they already gave us the density. They gave us the density right here. What we need to do is we need to figure out the volume. How are we going to go about doing that? What we're going to do is use our handy dandy volume formula, which you're going to find on the back of the Regents test. You'll see that reference page, and I can see that it's right here. It's 1/3 times base times height. And so let's do that right now. So if it's going to be volume equals 1/3 times the base. Well, what is the base? The base is the area of this square, which we know it's going to be 4.5 times 4.5, length times width. And what will that give us? 20.25 times the height. And what is the height? We already said the height is 10. And so when you pop that in your handy dandy calculator, that's going to give you 67.5. So this is the volume. Amazing. And so here's what I know. The volume is 67.5, and we're going to be multiplying it by the density, which is 0.676. That's going to give us the mass. And when you pop that in your handy dandy calculator, what exactly will that yield? The mass is going to be 45.63. And because we're looking at the nearest tenth of a gram, the correct answer is option number 1, 45.6. Question number 13. In the diagram below, right triangle EFG, we've got altitude FH intersecting the hypotenuse EG right here at H. Let's go ahead and mark up the diagram, but before I do that, I want to recognize a few things. I can see that we've got 3 overlapping similar triangles. We've got the small triangle, we've got the medium triangle, and then we've got this overall large triangle. So let's mark up the diagram, and I'm going to reflect the 90-degree angles and the 3 triangles I have to the right. And I know that this is a 90-degree angle because it says right triangle right here. So we've got the large. Let's go ahead and do the small now. I can see that the small triangle is triangle FHG. And then we've got the medium triangle, and I'm going to indicate the 90-degree angle right here, like so. Amazing. All right, so it says if FH is 9, and I'm going to mark that up right here. FH is 9, and I can see a few things. FH is the short side of the medium triangle. It's the long side of the small triangle, and we can see that it's not one of the outside side lengths of the large triangle. So we got that right there. And it says if EF is 15, so EF is this length right here. And what is that? That is the long length of the large triangle. It is the hypotenuse of the medium triangle. And because the small triangle right here has no relationship currently with this length, so we're not going to touch this diagram right here. And it says our objective. What is EG? All right, so we're breaking this down. This is our objective, and we can see that EG is right here. And so I know that EG is the hypotenuse of the large triangle. That's amazing. I can also see that it's a fraction of the medium triangle, right? It's the long leg of the medium triangle, and it's the short leg of the small triangle. But there are a few missing pieces. How can we approach this? What do we know? Well, here I can see that we've got a right triangle where we know 2 out of the 3 sides. How are we going to figure out what this third side is? Because that's going to help us sort of figure out the rest of the pieces of this puzzle. We're going to apply, of course, the Pythagorean theorem. And so we know that the Pythagorean theorem is a squared plus b squared equals c squared. C, of course, is always the hypotenuse. Let's plug in these values. So it's going to be 9 squared plus b squared equals c squared. 9 squared is 81. Our objective is b, right? So b is going to be, in the case of this triangle, this length right here, equals 15 squared, which I know is 225. We're going to subtract 81 from both sides, and when we do, we've got b squared equals 144. Let's take the square root of both sides because we want to isolate b, and when we do, I know that b equals 12. That's amazing. All right, so we now know that EH is 12, and so I can reflect that in our diagram to the right. So I know now that the long leg of the medium triangle is 12. That's amazing. So what can we do? Well, we know 3 sides of this medium triangle, and so now we can set up a proportion. So if we're going to want to figure out the other length of this side right here using the small triangle, we can then simply add the 2 to figure out the total sum of this entire side length, the hypotenuse of the large triangle. And let's go ahead and do that. So right now, this is our objective right here, and we'll call this x. Why not? Okay, so this is going to be x. This is our objective. All right, so let's go ahead and do that. Here's what I know. We're going to set up a proportion, and what we can do is we can do short length over long length equals short length over long length. So I'm going to jot that down right now. So I'm going to do short leg over long leg equals short leg over long leg. Now let's substitute those values in. So I know that the short leg we're going to call x equals what over what? So short leg over 9, that's the long leg, equals the short leg 9 over the long leg, which is 12. So again, we're doing the small triangle, the relationship between the small triangle and the medium triangle right here. And let's simply cross multiply. We're going to solve for x. Here is what I know. 9 times 9 is going to give us 81 equals 12x. And when we divide both sides by 12, 81 divided by 12 is what? What does that give us? I'm going to take out my handy dandy calculator. Okay. 81 divided by 12 gives us, 6 3/4. X equals 6.75. So I'm going to reflect that in our diagram. So this is 6.75. We know that this is 6.75. That's amazing, but that's not our objective. Our objective is this entire yellow length. So 12 plus 6.75 is what? Well, 12 plus 6, of course, is 18. 12 plus 6.75 is 18.75. That makes sense. The correct answer is option number 3. Question number 14. In triangle ABC below, point D is a point on AB and E is a point on AC, such that DE is parallel to BC. I'm going to go ahead and I'm going to mark that up to reflect that these two segments, DE and BC, are parallel to one another. So then it says, which statement is always true? All right, that's critical. But before I do anything, I'm going to recognize that these segments are parallel, and I'm going to be thinking about angle relationships as a result of parallel lines. And when I use my eyeballs, I can see that we've got AB as a transversal cutting across DE and BC. So another way to think about it is like parallel lines, transversal. And what do I know? I know that this angle and this angle are what? They're corresponding angles. That means that they're congruent. So I'm going to indicate that on our diagram. And so I also know that we've got a small triangle and a large triangle. Okay, and so that these two triangles share that angle right there. So what does that mean? I can immediately recognize that we've got similar triangles because of what? Because of AA. Okay, so this triangle is similar to this triangle. So now let's go ahead and evaluate possibilities, options 1 through 4. So the first option says that angle ADE, which is this green angle right here, and angle ABC, again, this green angle, are right angles. No, it looks like they're 90-degree angles, right? But there's nothing in here that would suggest that it is and that this is always true, so we can rule out option number 1. Option number 2, it says that triangle ADE, the small triangle, and triangle ABC, the bigger triangle, are similar to one another. And yeah, they are similar. And we know that because of angle. Option 2 is the correct answer. Question number 15. If one exterior angle of a triangle is acute, then the triangle must be what? So we're going to be classifying triangles. And to do that, we're going to need to look at some of the properties of triangles. And I recognize that if we're describing an acute angle, then that's an angle that's less than 90 degrees. And if we're also talking about an exterior angle, that's going to be kind of like this angle right here. But I recognize that this angle appears to be an obtuse angle, appears to be greater than 90 degrees. But I know that in this example, it's going to be less than 90 degrees because it's acute. So that's this angle right here. So this is the exterior. This is the exterior angle right here, less than 90 degrees, meaning that this angle right here, right, that we've got a linear pair, this angle is greater than 90 degrees. So how are we going to classify this triangle? It's an obtuse triangle because one angle is greater than 90 degrees. That's what we have. The correct answer is option number 3. Question number 16. Given the information marked on diagrams below, which pair of triangles cannot, and I'm going to highlight that, cannot always be proven congruent? So I'm going to recognize that we're going to have to draw an understanding of triangle congruence theorems. And we've got, of course, SSS, SAS, ASA, AAS, and HL. And presumably 3 of these 4 options will hit on one of these theorems. And let's start with option number 1. And the first thing that I'm going to do is always try to think, when we've got pairs of triangles, are there shared sides? And indeed there are right here. And I also know that if BCD is 90 degrees, then BCA has also got to be 90 degrees because they're a linear pair. And if that means that they add up to 180, if this is 90, this is 90. And what do we have? We've got side, angle, side, side, angle, side. And I know that side, angle, side is a way to prove 2 triangles congruent. So what we can do is eliminate option 1 as a possibility. Let's take a look at option 2. And we don't have any shared sides here. But what we do have is a vertical angle. And so I recognize that we've got angle, angle, side, and then angle, angle, side. Is that a way to prove 2 triangles congruent? It sure is. So we've got so far, SAS, we've got AAS. Let's take a look at option 3. And we're going to mark up this diagram. I can see that we've got another shared side. And so this one, of course, I can see right here is side, 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 meaning that option 4 is the only one left by a process of elimination. It's got to be the one that does not prove two triangles congruent. But when we sort of inspect this further, I can see that we've got side, side, angle, or angle, side, side. And sadly, that's not a thing. In order for this to be an option, what we would need is this angle right here to be inscribed or sort of sandwiched between the two sides. So option 4 is the correct answer. Question number 17. The diagram below shows a tree growing vertically on a hillside, and the angle formed by the tree trunk and the hillside is 100 degrees. The distance from the base of the tree to the bottom of the hill is 140 feet. And it says, what is the vertical drop, x, to the base of the hill, right there, to the nearest foot? So this is our objective, the vertical drop, which I'm going to indicate right here. And I recognize that we're going to need to draw on our understanding of trig ratios. And we're going to use this angle right here to sort of help us out. And here's what I know. I know that if this is 100 degrees, then because this is a linear pair, this has got to be 80. I also recognize that the sum of the three interior angles of a triangle add up to 180. So if this is 80 degrees, right, and this is 90, then this angle way over here has got to be 10 degrees. This is quite the acute angle. All right, and so let's set this up. If we're going to be thinking about it from this perspective, what is the relationship to 10 degrees between x, which is our objective, and this side right here? This is 140 feet. Well, I recognize that x is opposite, and 140 is always the hypotenuse because it's opposite that right angle. So let's set this up. It's going to be sine of 10 equals what over what? It's going to be, I know when we use this handy dandy chart, it's going to be opposite over hypotenuse. So it's going to be x over 140. And here's what I know. We want to isolate x, so we're going to multiply both sides by 140. And when we do, I know that this cancels out. And so x equals what? When you plug 140 sine 10 into your calculator, that's going to give you 24. And I'm using my, I'm looking at the four options we have. Option 1 is the correct answer. Question number 18, it says on the set of axes below, we've got two congruent triangles, and it says which sequence of rigid motions will map triangle LET onto triangle L double prime, E double prime, T double prime, and we've got four options. We're going to go through each one, starting with option number 1, and so I see that it says a reflection over the y-axis followed by a reflection over the x-axis. We're just going to select one point, and we're going to see how successful we are with mapping this triangle onto this triangle. We'll start with vertex L. And so here is what I know. If this is L, and it looks like we've got two steps, right? If it's a reflection over the y-axis, I can see that it's 1, 2, 3 units from the y-axis. So it's reflecting, it's going to go an additional 3, 1, 2, 3. So here we've got L prime. And then what does it say? It says a reflection over the x-axis. So now here is what I know. If it's 1, 2, 3, 4, 5, 6, it's going to go 1, 2, 3, 4, 5, 6. So L double prime is right here. And yet, on the example that we're looking for, L double prime should land right here. So what we can do is eliminate option 1 as a possibility. That's not checking out. So let's take a look at option number 2. It says a rotation of 180 degrees about the origin. So let's start with E right here. And so once we apply 180-degree rotation, it should land right here ideally, but I know for a fact that's not going to check out for a variety of reasons. One, I know that if it's 180 degrees and we're starting at the origin, it's right now we're going to go from 1 to the left and then 3 units up, right? And so to perform 180-degree rotation, we're going to go 1 to the right and then 3 down. And so it should be right there. And yet E double prime on this triangle is all the way up here. But I also know if we were so inclined, we can apply the specific algorithm or the rules to determine how to figure out where it would land on a coordinate grid using these coordinates, right? So xy becomes negative x, negative y. And if this is, what is it, negative 1, comma 3, and here we've got what? We've got 1, negative 3. That's the rule, and yet that's not bringing us to this point right here. So option 2 is also not a possibility. Let's take a look at option number 3. It says a rotation of 90 degrees counterclockwise. So that's simply a 90-degree rotation. And then it says followed by reflection over the y-axis. So let's take a look at that. And you know, it might as well let's stay with point E. All right. So if it says if it's a 90-degree rotation, and we just said that the coordinate is negative 1, comma 3, what do I know? I know that we're going to flip it, and so it's going to be negative 3, comma 1. And so again, here's what I know. We're going to flip-flop the x and the y value as we did, and then we're going to negate that first place, right? So it's going to be negative 3, comma 1. And let's do that right here. Negative 3, negative 1. Okay. And then it says it's going to be a reflection. And actually, let's indicate that right here. So here we've got E prime. And then it says critically followed by reflection over the y-axis. So here's the y-axis. And I'm going to count over. 1, 2, 3. And then let's count again. 1, 2, 3. Okay, ladies and gentlemen, this checks out. This is the correct answer. And so what we can do is we can simply eliminate option number 4. But if it says it's a reflection over, let's try with E again, a reflection over the x-axis. So it's going to be approximately right here, followed by a 90-degree rotation about the origin. And so, yeah, that's not going to work either. We can eliminate option 4. Option 3 checks out. Question number 19. Diameter ROQ of circle O is extended through Q to point P, and tangent PA is drawn. And it says if the angle of arc RA is 100 degrees, what is the angle of angle P? And so that's our objective. But I also know that this is kind of a crazy problem unless we sketch it out. We're definitely want to draw out this diagram. So I'm using my eyeballs, and I can't help but notice it says diameter ROQ. So that's the first thing that I'm going to do. So I'm going to draw this diameter. And I know that this is O because it's of circle O. And I know that we've got R and we've got Q. And then it says it's extended through Q to point P. Okay. And then it says tangent PA is drawn. Okay, so here we've got point P. And then we've got PA is drawn. And it says if angle RA is 100 degrees. So let's indicate that like so. So if this is 100 degrees, it says what is angle P? And we'll have that indicated right here. So I'm going to indicate that as an X. All right, how are we going to figure that out? Well, I know a few things. I know that when we're talking about angle relationships involving secants and tangents, I'm actually going to sketch this out again. I know that theta, which in this case is what we're looking for, right? This angle right here, is equal to big arc minus small arc divided by 2. And so I'm gonna sketch that out right now. So angle theta, or x, is equal to big arc minus small arc divided by 2. Okay, so now if we use this formula, we can simply solve for x. All right, so here's what I know, and this is pretty important. If this is the diameter, right, and then this is 100 degrees, what is the angle of this arc right here? Well, we know that a whole circle is 360 degrees. 360 divided by 2 is 180, so that if this is 100, and this arc right here has got to be 80 degrees, and that makes sense, right? And so let's apply this formula. So it's going to be angle x, which is what we're looking for, equals 100 minus 80. And I know 100 minus 80 is what, 20. 20 divided by 2 is 10. So angle x equals 10. Is that an option? And by angle x, we're talking about, of course, angle p. Is that an option? It is. It's option number 1. Question number 20. Segment JM has endpoints -5, 1 and 7, -9. An equation of the perpendicular bisector of JM is what? And so the equation that we're looking for amongst these 4 options is going to be expressed in point slope form, which we know is y minus y1 equals m, the slope, right, times x minus x1. Amazing. And we're going to approach this algebraically for sure, but I always like to sort of plot things out graphically so I can sort of like make sense of what's happening here. And I can see that j is -5, 1. Amazing. And m is 7, -9. All right, and so this segment, it's going to look a little something like this. So I'm sort of just sketching this out loosely, and I know that if this is a perpendicular bisector, it's bisecting it, so it's going to be cutting it in half approximately right here. And if it's perpendicular, it's going to be creating a 90-degree angle. Let's go ahead and do that. Let's first start with the midpoint. And I know that's the average of the x values and the average of the y values. So let's find the midpoint. Beautiful. All right, so it's going to be the sum of the x values, and the x values are -5 and 7. All right, and so -5 plus 7 is going to give us 2. 2 divided by 2 is 1. All right, so the x value is 1. And what about the y value? Again, it's the sum of the y values divided by 2. And so the y values are 1 and -9. All right. So -9 plus 1 is -8. -8 divided by 2 is -4. We just figured out what our midpoint is. Amazing. All right. So our midpoint is it's precisely right here. Beautiful. And so now what do we need? Now we need the slope. Okay. And so the first thing that we're going to need to do is figure out what the slope is of JM, and then we're going to find the negative reciprocal, and so it can tell us what the equation is of this perpendicular bisector. Great. So the slope is the change in y values over the change in x values. And so let's do that. Let's do that right now. So the change in y values is -9 minus 1 over 7 minus -5. And that gives us what? So -9 minus 1 gives us -10. And then 7 minus -5 gives us 12. So the slope of this equation simplifies to -5 over 6. All right. And what do I know? I know that the perpendicular slope is the negative reciprocal. So it's going to be not -5 over 6, but positive 6 over 5. Beautiful. Okay, so this is what we're looking for in amongst our 4 options. And so if the slope of the perpendicular bisector is 6 over 5. We can rule out options 1 and 2. So we know that 1 does not work and option 2 does not work. And what I know is that because we're popping this into this equation right here, and this is these are the coordinates that we're going to use, I know that -4 pops into right here because we're doing y minus -4, which gives us +4. And then x minus x1, which is simply 1, yields the correct answer. Option 4 is what we're looking for. Question number 21. Quadrilateral EBCF and segment AD are drawn below such that ABCD is a parallelogram, okay, and that EB is congruent to FB, and that EF and FH are perpendicular. Amazing. So I'm actually going to mark that up right now. So I know that this forms a 90-degree angle, and I can see that EB is congruent to FB. Amazing. And so I'm going to think about a couple things right now before I go ahead and indicate the angle measure of angle E and C, and that is this. I know that right here I can see that we've got an isosceles triangle, which we know is when we've got two triangles that are congruent. And I also know that base angles of an isosceles triangle are congruent. And so here's what I know. If that angle that we're talking, if that triangle that we're talking about is this triangle right here, we've got two congruent sides, and then we've got base angles being congruent. All right, and so what do I know then? If angle E is 62 degrees, okay, this is 62, and then by that logic, this has also got to be 62 degrees. Amazing. And then it says if angle C is 51 degrees, so this is 51, our objective is to figure out the angle measure of FHB. So FHB is this angle right here. So this is that's what we're trying to figure out. Okay, how are we going to go about doing that? Well, I know a few things. We're going to try to sort of put the pieces to this puzzle together, and I know that if we can figure out the sum of this angle and this angle, we can then figure out what angle FHB is, because we recall that the sum of the three interior angles of a triangle is 180. Can we figure out what this slice is right here? Absolutely. We know that if angle EFH is 90 degrees, right, what do we know? We know that 90 minus 62 is going to give us 28 degrees. Okay, so we know that this is 28 in here. How can we figure out what this is? Well, there's a few different ways to go about doing that. I know that if this is a triangle right here, 62 plus 62 is what? Well, 60 plus 60 is 120. So this is going to be 124. So how many degrees does this have to be? 180 minus 124 is going to give us 56. Beautiful. Okay, so 56 is this angle right here. And this is not, sadly, a linear pair. If it was, that would be too easy, right? So how are we going to go about determining what the value is of this angle? Well, I know a few things. I know that if it says critically that ABCD is a parallelogram. And one of the things I know about parallelograms is that opposite sides are parallel. And so here we've got BC, and we've got AD parallel to one another. And then we've got a transversal cutting through it, which is BA, and CD, right? And so if CD is 51 degrees, I know that this is 51 degrees right here. Opposite angles in a parallelogram are also congruent. And I know that this angle and this angle are supplementary, meaning that this angle and this angle adds up to 180. So 56 plus 51 is what? 107. So this has got to be 73 degrees, right? All right, I'm going to indicate that right here. So 50, actually, 129. This is 73. That makes sense. So here's the critical information. 73 and 28. How are we going to figure out what x is? 73 plus 28 gives us 101. Okay, and then let's write that right here. 73 plus 28 gives us 101. So then 180 minus 101 is going to give us 79. So x equals 79 degrees. Is that an option? It absolutely is. It's option number 1. Question number 22. Point P divides the directed line segment from point A to point B in the ratio of 2 to 3. The coordinates of point P are what? Well, the first thing that I'm going to do is I'm going to sketch out this segment, and I know we're going from A to B. And I notice, and this is really, really important, that it's a ratio of 2 to 3, meaning there's a total of 5 parts. So we're going to do, we got 1, 2, 3, 4, 5. Beautiful. All right, and so where's point P? Point P is where it splits this into a 2 to 3 ratio. We got 1, 2, and then we got 1, 2, 3. So point P, of course, is going to be right here, and this is critical. This is the coordinate that we're looking for. So A is going to be -4, -1, and then B is going to be 6, 4. Beautiful. How are we going to figure that out? Well, what we're going to want to do is determine how much the values are changing as we jump from point to point. And to do that, what we're going to want to do first is figure out what the distance is of the x values. So let's go ahead and do that. So I know that it's going to be x2 minus x1, so that's going to be 6 minus -4, giving us 10. The distance of x values is 10, and that makes sense. And then the y values are going to be 4 minus -1, which is going to give us +5. All right, and so we're now going to take that distance of the x values, which we'll recall is 10, divided by the number of parts, which is clearly is 5. And so the change per part is going to be +2. It's increasing by 2 units as we shift from point to point. And let's take a look at the y values. It's going to be 5 divided by 5, giving us a +1 increase. All right, so let's go ahead and figure that out. So if it's changing 2 each time, -4 plus 2 is going to give us -2. And then -1 plus 1 is going to give us 0. All right, but we don't really care about that coordinate. What's really critical is the next coordinate. So -2 plus 2 is going to give us 0. All right, and then 0 plus 1 is going to give us simply 1. That's pretty easy. And this is our answer. This is the coordinate that we're looking for, and the correct answer is option number 2. Question number 23. A line is dilated by a scale factor of 1/3, centered at a point on the line. Which statement is correct about the image of the line? Well, the first thing I know is that when we're dilating a line, the slope does not change. So I know that we can eliminate option 1, where it says its slope is changed by a scale factor of 1/3. Nope. Whenever, again, we're dilating a line, the slope does not change. What else do we know? I can see it says that it's centered at a point on the line. So if it's on the line, that means that it's not going to change. The image of the line and the pre-image are the same line. Question number 24. In the diagram below, we got circle O, tangent AB is drawn from external point B, and secant BCOE and diameter AOD are drawn. All right, and it says if angle OBA is 36 degrees, and I'm going to mark that up, 36, and OC is 10, what is the area of the shaded sector. All right, that's our objective. And we've got 4 options. Notice that all are expressed in terms of pi. How are we going to go about doing that? Well, my eye is really drawn to this language right here, tangent AB. And we'll recall that a tangent forms a 90-degree angle with the radius. And that comes in really handy because, again, we're going to try to figure out what the area of this is. And we need to know how many degrees this sector is. And we're going to figure that out right now. So if this angle right here is 90, I know that 180 minus what? Well, 90 plus 36 is going to give us 126. So 180 minus 126 is 54. So if this is 54, then this has got to be also 54 because they're vertical angles. And here's what I know. I know that we want to figure out what the radius is of this sector. And if this is 10, this is 10, and then likewise both OE and OD are also 10 units. Amazing. All right, let's go ahead and do this. The way I sometimes set this up is simply setting up as a proportion. And so I know that if it's going to be 54 degrees, which is just a fraction of the entire 360, equals what over what. So if we're talking about degrees and then area, the area is what we're looking for. And we don't know that, so we're simply going to write x. And I know that it's the area of the entire circle is pi r squared. And in this case, r is 10. Amazing. So let's go ahead and simplify this. So it's going to be 54 over 360 equals x over 100 pi. And then we've got 5400 pi equals 360x because we just cross multiplied. And then, ladies and gentlemen, because we want to isolate x, when we divide both sides by 360, what do we get? We get x equals 15 pi. Is that an option? It is. It's option number 4. Thanks for sticking around for the multiple choice questions. If this was helpful for you, please like and subscribe. I'm going to be explaining the solutions to the constructed response questions for the June 2022 Regents in another video, so stay tuned.